The first talk in the afternoon is from Mateusz Pusz. Well, I already introduced him yesterday. You know him. He's been giving a talk here before, so he's not the first time. He's a well-known trainer. In fact, on Tuesday he was giving here a training on concurrency. And he usually delivers a lot of trainings about many topics in C++, and he is also a member of the ISO C++ committee representing Poland. So Mateusz, thank you very much for being here again. Surprisingly, he's not going to talk about concurrency, and he's not going to talk, I think, about MP units. You never know. He's going to talk about friendship. So that means that we are all friends. So go ahead, Mateusz.
All right, so welcome everyone. I'm happy to see you all here, and let's start. Yeah, my name is Mateusz Pusz. I was introduced already, so I will skip that part. I want to talk about making friends in C++. Making friends in C++ is sometimes quite challenging, sometimes also considered not the best idea or not the best practice, because I don't know why we can't have friends, right? Let's try to dig into this subject a bit and find out what's good, what's wrong about having friends in C++, and how we can tame them to be better. First, I know that we already did it many times today, but did you use friend in your production projects? Most of you. Yes, this is what I expected. Right, so this is a keyword that was here with us for many, many years, but I still think that it's worth talking about because, well, there are not many talks about it, and still there's plenty of misconceptions about how it can be used. I would claim that frame is a really powerful tool, but like art, it requires skill, understanding, and careful application. It can be overused, it can be underused as well, and we are here today to learn the best use cases for this utility. All right? So let's start with a single program. This single program has only a few lines, and as probably most of you already realize, this program will not compile. Right? This program does not compile because we want to print something with our operator here, string operator, for a value being inside the structure, and of course, we didn't provide a customization point to perform such operation. Right? So we get a compile time error. In order to make it work, we have to provide a customization point. In this case, customization point is the string insertion operator. And with this case, we teach our framework how to print our class to the output. Most frameworks that are customizable depend on argument-dependent name lookup to find the customization point provided by the user for a user-defined type. Right? We don't have much time to talk about ADL here. I spent an entire hour talking about it on CPPCon, so I recommend you going to this talk if you want to learn more about ADL. But briefly speaking, argument-dependent name lookup is a process that compiler does to find a name that is referred by so-called unqualified name. So if you don't specify any colons on the left-hand side of it, so you basically say just find it by name, not by specific path, let's say, then compiler performs several steps to find it, and one of those steps is using argument-dependent name lookup. This lookup checks for this identifier, for this function overload, in the namespaces of the arguments of the function. Right? So it takes the arguments of the function and looks for this overload in all of the namespaces associated with those arguments. Roughly, because there are more details, but not today. More in the talk. So let's add this customization point to our type. And who thinks that this doesn't compile right now? Hand it up. What might be the reason for this? It doesn't compile? Well, yes, the values could be private because if I was not that nasty to you right now, because I just printed struct there, right? So the value actually is public, so yeah, it works, right? But of course, what you expected is to see class there, and with class it will not work. Typically, it will not be printed, right? And by this, I just wanted to refer to one statement that was provided earlier today, that the specifiers, access specifiers to the class are not useful at all in C++. I don't actually agree with that. It's really important to be able to specify the inner implementation details and encapsulate them from the users, so the users do not have to basically do not have access to this, cannot break invariance of the class, and so on. Right? So let's maybe briefly just remind what are the access specifiers for the class member access control. Right? We have public members, we have protected members, and we have private members. Right? Public members are accessible by everyone, protected by the current class and its children, and private only by the current class. So for classes, we have always private access, both to the members and also during inheritance, which sometimes is missed by some of my students, right? So that's why I'm explicit about it. So if in case you want to have public inheritance, you have to type public. In case you want to have private members, you don't have to repeat private, it's private by default. With struct, it's exactly the opposite. You have public inheritance, so you don't have to type public for this inheritance, but you need to put members in the private section. Typically, you can put it on in the end to benefit from the public section in the beginning. Of course, you can solve the previous problem by adding a getter. Getters sometimes are a solution, but typically are not a good solution, right? So don't add getters in order to print things like this. Of course, actually int may have some sense to return the underlying value in some cases, but do not do it only to print, to use streaming operator. If you need such an API in different places, of course you can add a getter. But just to print the streaming operator, it's not a good idea to add a getter to it, especially a getter that will return you a reference to an underlying type, because copy is not that bad in this case. Right? With adding a getter, you always expose implementation details of your class, which makes it much harder to refactor later on. Assuming that my underlying type is int right now and I would like to change it to something else in the future, I would break user's interface in case I would expose this getter before. Right? So it actually breaks my encapsulation. It makes it harder to refactor the code later on. And also, if you do it incorrectly, as I said, returning by reference, for example, users may break invariance of the classes by directly accessing members and mutating their values. Let's see another example, right? Here I have operator plus for this myInt. Operator plus implemented as member operator. So it just takes one argument, and it sometimes works, right? It sometimes works, but actually not all of those lines will properly work. Right? The last line doesn't compile. The last line doesn't compile because here we are not doing operation onto myInt classes, objects of myInt types. We are doing operations on the myInt type and an integer value. In order for them to add, according to this operator, both of them have, when the int has to be converted to myInt, so both of them are myInt types. Conversion works only on the right-hand side argument, so in this case, this one, but will not work on this one because in this case, the compiler will look for operator plus for integers, not from our class. That's why it is not recommended strongly to do those binary operators as member functions, right? So binary operators should typically be overloaded on non-member functions. In this case, we have implicit conversions for both arguments, which is what is desired here. And of course, again, I can use my getter that I had before, but it's not a good idea. But it works. Of course, I could also implement this in terms of other operator, assuming I have it, because right now I don't have it, but if I have it, then I can use it, and I don't have problems with friends, because I could benefit from the public interface of the operators in our class. But that's not the subject of this talk. So I state that access control is the key principle of C++. Right? Some non-member functions need access to class private members, and many of them can't or should not be implemented as member functions, like operator plus. Like streaming operator also can be implemented as a member. So you have to implement this as non-member, and sometimes they need access to private members of your class. So what you do friends, right? Probably every one of you already implemented at least a few of those, so there's nothing new in this slide for you. So we grant access to our friend, and it can access our private members. And then it will work. We'll have conversions on the left-hand side, right-hand side. We can print the value as a result, and everything is fine. So what is a friend keyword? It grants a function or a class access to private or protected data members of another class, right? Not only private or not only protected, but for both of them, right? Traditionally, this is used when external function or external class requires access to your implementation details. That's why sometimes it is considered to be not a best practice, but I would like to discuss a bit more during the talk today. So, first, we have two columns with the same code, just the friends here are put in the public or private section of the code. Do you think there's any observable side effect, any difference during compilation process, behavior, whatsoever, between those two? What does it mean to have private friends or public friends? Is there any difference? I see people saying no, and you are right. There's no difference how you do it. It works in both cases. In both cases, you will be able to basically have access to the private members, and it actually doesn't matter when you put those friend declarations. So, access specifier has no effect on meaning of friend declarations. Friend declarations can appear in private and public sections with no difference. What entities can be our friends? We can have friend functions, non-member and member functions. We may have classes. We may have another templates. Templates being, so generators being our friends as well. So generators of function templates and class templates and member function templates, right, in this case. So non-member, member function templates and class templates may be our friends as well. Let's see slightly different example where we have bank account. Bank account that has some amount and you want to transfer money from one account to another. Right? I can implement this way with different. Right? I say I have function transfer funds that is our friend, has access to our balance, and can modify our balance of the account. This, of course, is not thread safe. We talked about this during the training a few days ago, exactly the same example. So don't do it in concurrency. But for single-threaded code, it's fine. If I want to add access to some other class, for example, I want to have a transaction as a class because I have some needs for it for testing, mocking, whatever, or provide some additional behavior to it, and I have polymorphisms here, even worse, still I can make a transfer a friend of our class. In this case, I have run that has from, to, and amount, right? And I have check balance that checks the balance, and if balance is okay, then I transfer from amount. So this transfer actually will change the balance of our accounts. So this transfer has to be our friend. So I make this function a friend of our bank account. Does it compile? Who thinks it compiles? Who think there's a problem in compilation? Who doesn't know? All right. Most of you don't know. All right. So it doesn't compile. It doesn't compile because transfer is a private function. In order to say that the transfer is our friend, which is a private function of transaction, we have to actually add information that bank account is our friend as well. So you can actually make the other function our friend. It's a bit strange, but this is how it works. And do you think that this compiles right now? I see hands up, more people. Still, it doesn't compile. I just moved the class declaration from before the class to the friend declaration here, right? And the friend declaration does not declare a class actually inside of this class. So this bank account is unknown in this case. So I have to provide first so friend declaration does not declare a class actually, right? Explicit class declaration is still needed. So I have to put bank account first, then say this class is our friend. I don't need the class keyword anymore. And then all of this compiles fine. And I can implement my function, finally having access to balance. In case my transfer fund is a template, for example, I want to use some representation type for our rep here, then this is how I specify the transfer funds is our friend. I say in this case that transfer funds of any rep is my friend. This is how I specify it in the code, and then every transfer funds overload for any rep will have access to our balance. In case our bank account is a rep, is also a class template, we can say that we want to provide the friendship only to specializations of transfer funds that is also specialized for the same rep. So this is how you specify it, or also you can just provide those diamond operators because rep is by default provided for the class for all of the elements, right? We don't specify here bank account, for example, of rep because we don't have to type it. We don't have to type it here as well. So this is the default in this class template. So those were just a bit more advanced examples because I often get answers how to make friend declaration to compile for templates because it's a bit harder. In case you have class template and you want to make another class template friend, you may say that any instantiation of B will be friend of A. Or you may say that only B of T's will be friends of A of T's. Or you may say that B of int will be a friend of A. So you have control who is a friend of your class. All right. So now let's talk about encapsulation. My private definition of encapsulation is that encapsulation is the art of bundling data and behavior associated with some single responsibility principle behind a clean interface. Concealing implementation details, so you can change them easily, right? And securing class invariants. If you can't refactor easily, that's not a proper encapsulation. Because encapsulation, among others, is to allow you to change code without breaking your users. It's not only about hiding stuff, as many people think. And I have a question. Can adding a member function decrease encapsulation? Because typically, my students say, we are adding more member functions, everything to a class, because this is how encapsulation works. Right? From object-oriented programming, we know that we have objects, we have some data members, and we have functions, and this is what is called encapsulation. There's a really nice article by Scott Myers, where you can actually read that he says that in case you can live with both use cases, non-member and member function, you should always select non-member because this actually improves encapsulation. Right? Member functions often increase coupling and decrease encapsulation. My perfect example of really, really bad designed class is this one. If you can't read the overloads, well, there's just too many of them. And we keep adding more and more with every release. Don't do it. Now consider, I want to change the internal implementation. How many functions I have to change? Is it proper encapsulation? String should really have something like 15 members top, and all of the rest should be non-member. Or maybe some view that can be put on top of the string and provide all of the string interface. You really don't need to put all of those functions into your objects in order to increase encapsulation. And moreover, we plan to actually add more string classes to the language. We discussed basic fixed string. We discussed in-place string to be added. And in-place string will be nasty because it will have to add exactly the same overloads because it has to be dropped in replacement for that. Which means compiler vendors have to implement another class with all of those overloads, which means that during standardization, we have to remember to add overloads to both classes, which means that we have to write standards for all of this and then process wording for all of this as well. And the paper will be just longer. That's not proper encapsulation, right? So now I have a question, because I often hear that friend in C++ violates encapsulation, and that's why you should not do it. C++ FAQ says explicitly that a friend function in the class declaration doesn't violate encapsulation any more than the public member violates encapsulation. As we just said, public members of a class make the class less encapsulated, right? There's a problem. And doing a member function, the friend function is exactly the same. It has exactly the same access to private and protected data members as the member function. It's no different. The only difference is that how you can call it from external code, either through dot and then function or the function and an argument. This is the only difference. In terms of encapsulation, it is exactly the same. Maybe in case of maintenance, this is a bit bigger problem because there's like more lines and friend is outside declared, but we are going to get to this in a few minutes. A few more rules about friendship. Friendship in C++ is not inherited, right? So this means that if X has a friend called base, base can access value, but derived cannot. Right? We get an error if we try. Tight coupling between classes is fine when they are maintained and implemented by the same developer, the same team, the same company, right? So as long as they are tightly coupled and connected together, they are fine. But giving access to the users that may produce as many different classes as they need and have access to our private members probably is not wise. So this is a good default. Having two classes being friends together makes sense because typically we make friends between classes if two classes cannot be implemented as one. They have to be splitted. For example, because they have one responsibility but different lifetime. In this case, you cannot have one object, you need two. But as they have the same responsibility, they together make a whole, they often need to be friends to each other. Friendship is not transitive. So if y is a friend of x and z is a friend of y, then z is not friend of x. Right? And friendship in C++ is not mutual. If someone calls me a friend, I don't necessarily have to consider this person a friend as well. So again, quoting C++ FAQ. Just because I grant you friendship access to me, it doesn't automatically grant your kids access to me, your friends access to me, and you access to me. Right? Me access to you, sorry. Yeah, I messed up. So this is the rules of friendship in C++. Friend is often overused in unit testing. Friend is not a solution for unit testing. I will repeat again. Friend is not a solution for unit testing. Please don't do it. Okay? Don't provide some friend classes to your public interfaces just to then have access private to test that. It breaks encapsulations, increases coupling between test and implementation. If you change any implementation details in your class, you have to change all of the tests. Not breaking changes to private members require modifying tests, which is a problem. It encourages bad design, leads to testing internal details instead of behavior. What should you do instead if friends is not a good solution? First, apply single responsibility principle. Typically, you need access to private implementations of your classes because your classes do too much. And that's why you want to test those separate features of this class. If you split it to smaller pieces, each of them being properly encapsulated, having public interfaces, you can test each class separately, independently, and then there's no problem. And just compose. And by doing this, actually, you will have less tests because you don't need to have all of those possible combinations of those cases, right? Each thing is tested once and then reused rather than requiring you to actually retest every time you want to use it, right? Of course, you can use additional properties and features like dependency injection to improve testability. You can use mocking as well. And don't do getters only for testing as well, right? Because I've seen this as well. Don't expose your implementation details only for someone because they want to test implementation details. That's not a good idea. That's not a reason to do so. And please, please, please don't do it. You may laugh, but I've seen this in production. All right. So those are the rules about the unit tests. One friend is not needed. Sometimes you may be surprised, but for example, if you have a class template or class that has some internal defined class, like in this case, we have some storage and you have some iterator, then in case your iterator will need an access to your storage, it doesn't have to be a friend. Member classes have friends to their encapsulating classes by default. So you don't need to make them friends. It just works. All right, so friendship in this case is not needed. So those are cases where actually friends is not needed. I read a really nice article by Arne Mertz some time ago, and he mentioned that friendship is the strongest coupling you can do in C++, and I agree with that. It's even stronger than inheritance, so you better be careful and avoid it if possible. With maybe the last statement, I'm not that sure because I will talk about some good friends later on. But in case of design between two classes, for example, like we discussed so far, yes, in this case, be careful when you do friends, right? Often it is seen as an indicator of a poor design, mostly caused by the lack of friendship granularity. You have either no access or have access to everything, which may be problematic as well, especially if you have those monoliths that do not have single responsibility principle. And also threatens class invariance, because friend can mess up with everything you have there. As a solution to this, you may apply some special patterns. But let's first see some use case with no patterns applied, right? I have some secure session that has a factory that will, for example, verify the URL because I'm living in an environment that exceptions are not welcomed, which, well, I'm not the biggest fan of not using exceptions, but there are places where actually exceptions are not being used. So in these cases, you may specify constructor as no except, and this means that it's really hard to propagate an error if this URL passed by the user is not valid, right? So in this case, you may want to create a factory that will validate the input, and only if it's correct, then create a factory, create the object through the factory. right? But this class doesn't have only a constructor being private, it has also some random token for the session to generate it, and then have handle and the secret token here. And our factory have access to everything, right? So I have session factory that creates our make secure session based on URL, validates URL, returns null if it's wrong. If it's okay, calls the private constructor here with the proper URL. And provides additional interface that actually can mess up with our secret token, because it has access to everything. If that's your concern, and there are some designs where I've seen this being a concern, you can apply this pattern that was invented by, or invented, or basically described by Arnemertz, constructor key. Right? I created a constructor key. I said that session factory is my friend, and I provided private default construction and private copy construction here. They are properly implemented, but private. And then here, I added this constructor key as a secret argument to our constructor that in this case is public. It doesn't have to be private anymore. It's public, but only the session factory can create a secret argument of it. By adding those braces here, you basically construct this constructor key, and you are the only one, thanks to this friend, that is allowed to call those constructors. So this basically works, creates, and propagandally gives you access only to the constructor while leaving the secret token and handle being private. Question?
Doesn't the constructor key type need to be public within secure session?
The question is this...
Can session factory refer to construction key when construction key itself is private within secure session?
Yes, the question is the construction key should be public? It doesn't have to be, because the user that is creating it is our friend. The rest of the users are not concerned with this key. I don't want the users and entirely in my code base to use this class for some other needs, right? If this is public, then I may find out that someone uses my constructor key of secure session to secure some other connection. And then I cannot, for example, refactor stuff because it started to be used too often.
I would need to check it, but my understanding is that the factory itself cannot refer to the type if it's not a public type.
The factory is a friend of us, so factory can access.
It's a
So
friend of
yeah.
constructor, but not of secure session.
Yeah, but the factory never actually mentions this key here, the type of it. Doesn't have to. If I would like to use the type explicitly, then yes, I cannot use it from this point.
Okay.
But with just the aggregate initialization, I can initialize it without knowing the type.
Okay.
It's similar to modules, right? You may have something that's accessible but not visible. All right, so this is one possibility, right? Before C++20, the default constructor actually has to be defined, not just defaulted. So beware, if you are before 20, you have to put those empty curlies, which I hate typically in production, and try to find them. But in this case, it is needed. Because otherwise, it could be created with an aggregate initialization before 20. From 20, this is not an aggregate anymore, so aggregate initialization actually will not work. It was actually the value initialization, what I showed. Also, the copy constructor needs to be private because someone may do this hack. May create a pointer of our constructor key, assuming it's public, right? And then pass it here, dereferencing it. Of course, it's UB, but compiler will compile this and allow you the access to this constructor. Another idiom that may be used to limit the access to our friends is so-called attorney-client idiom. This idiom basically provides you another class that is factory attorney, and we say that our friend is session factory, and we expose function make, the only one function here being private. And again, this class is public. Our constructor remains private here. And now session factory have access only to attorney and calls make. And this is the only thing that can do, but cannot use our handle or generate random token or any other stuff in class. So with this, you can have granularity of what you're exposing to which type in your ecosystem. Right? But still, I would prefer to have things, if possible, to use single exposability principle, and then you don't have those issues. Right? Typically, it's a problem when you have many things inside and you want to limit access to customers to specific things. All right. So those are the rules for the friends. Those are quite simple. I assume that most of you know it, but I would like to show you the use case from my library, MP units. You thought I will talk about it, right? Actually, not to refer to MP units yet, but this is where actually I started to find problems with approaching to friendship. So right now, let's discuss a bit how we can tame our C++ friends in the code base. This is just recap. I showed you this before, right? This is how you implement the streaming operator for our custom type. The problem starts to appear when I want to make it a template. When I want to make a template, I need a bit more. I need to provide declarations of the templates and basically then specify them as friends. And it seems I'm done, but it's not, because the code I just created is not the same as the previous one. If I try to do these conversions, they do not work, because template will not convert that easily like it was the case for non-template arguments in non-template functions, right? So conversion for function parameters for templates and non-template functions is different. Actually, it's not about functions, it's about if argument is depending on the specific parameter t or not. If it's dependent, then we only do something called parameter adjustment, parameter argument adjustment process, which is similar to decay, what it does, right? So basically it will remove all of the const, all of the references, all of the volatiles, and also replace the array with the pointer to the first element of the array, and function being a function pointer. This is what is being done. We considered some alternatives, but this consideration is only very limited. We consider more CV qualified pointers and differences and base classes, and that's it. Those are the only conversions we can do for dependent names in our class template, function template. No additional conversions. With non-dependent names, we have trivial conversions, promotions, standard conversions, user-defined conversions. So making a function template that basically works with class templates at this moment makes the code different, and you have to deal with it and provide additional overloads. All right? So with this, I had to add those additional overloads that basically take T from the right-hand side and left-hand side, make them friends again, and then implement them again. And okay, my conversions, right now I'm taking T explicitly, so that's not a conversion. I'm just adding the value here, works. If T is cheap to move or copy, then I can actually get rid of friends because I can create my object from this T, which involves the copy or move, if needed, and then I can benefit from the other operator that's already a friend of our class. But it may have additional cost if the class is expensive to copy. But it still doesn't work as I would like to, because I would like it to work with different types as well, like int and short together. If I try to make it work, I have a long error stating that basically my int and my short are totally different types. They don't know anything about each other, and I would like to actually be able to work with them like on regular integers and shorts. So I have to provide additional logic. First, I have to say that any instantiation of my int for any integral type is actually my friend. then all of the functions I implemented before have to return common type of those two. That's simplification, but let's deal with that for the moment, for this talk. And they have to provide constructor that, assuming that T is convertible to U, sorry, U is convertible to T, then this constructor will be valid and will be called and just will convert the value from one to another during initialization. And now, of course, everything works. A bit more friends, a bit more functions, some constraints, and it works. But then I want to implement things like that. A type that is really simple one, and it converts to my int. All right, and I want to type I plus 0 should be I. 0 plus I should be I from in both directions. And this worked for my non-template version, but for this case, it doesn't work, right? If I have templates. For templates, again, it doesn't convert. Of course, we could add more templates to and more friends to our class, but I would assume that at this point, most people will give up, or maybe even not check this condition. So how we can improve that? To not type so many functions, so many friends, and so on. Before I actually go into it, I would like to come back to my first slide that I showed you, saying that this doesn't compile. And I showed you the error message. I lied. This is not the error message. This is the error message. For Clang. And 128 lines more, right? And I'm actually lucky because I use Clang. GCC. With 300 lines more. All right? The inevitable effect of popular customization engines and the customization points is that you have plenty of overloads of the functions with the same name. Right? And then all of them has to be considered during this overload resolution process, and that's why the errors are so long, because compiler says, I tried all of those cases for you, and none of them is fine, and this is why. Name lookup and overload resolution are often the most expensive part of compile and performance in our production projects. We often blame templates for that. We say that we use templates, that's why it's slow. It has to be slow because we use templates. And templates are wrong because compile times are bad. Typically, it's not the issue. The issue is lookup, because unqualified lookup is longer than qualified lookup, and I think that Daniela here agrees, because she did some exercises lately with that, right? So doing qualified lookup already improves a lot, and actually removes all of these problems with the unqualified lookup or the argument-dependent lookup. But also overload resolution process in case of ADL and so other overloads is an issue as well, a big issue. Just to provide you another example where you see all of those overloads being presented, here is when I actually created a broken my float class template similar to my int, where I actually forgot to add operator plus, and when I actually want my float with another double, I actually see all of the overloads for ints, which is probably not what I wanted to see, right? Why the compiler proposes me overloads for ints if I'm working on float and double? It's not the case, but this is in the namespace. The name is the same, so compiler has to take care about that and consider those for the overload resolution process. So, have you ever blamed the templates for slow compile times of your project? I assume that many of you did, because I hear it so often during my trainings. Are you really sure that was the issue? I really recommend trying to using more of qualified lookup and practices from the next slides in order to check if actually the templates is a problem. You can be surprised how faster your project may compile. So let's refactor my int. What I did, I just put all of the definitions into a class. Notice how much shorter it is, because I don't need to predefine templates first, then define them friends, then define them below. So I already saved stuff, because during my trainings, I often say to my students, be lazy. Being lazy in C++ is so good. Don't type things you don't have to type. Because if you type something, typically it may be wrong. Right? I also added additional overload that was not possible before to be added, this operator plus. Notice, it is not a template at all. And with this, I can nicely handle all of those conversions that didn't work for me before. Right? It was impossible to implement this function before for a class template, having a friend defined externally to our class. The only difference is that I have friend keyword in the beginning here, right? And everything works together with the 0 that we gave up a few slides ago. No need to declare anything, as everything is defined inside of a class template. No functions, templates for adding declarations, no friend declarations, right? Conversions from 0 work as expected, as it was the case in non-template class for my int. The remaining arithmetics with other types work thanks to additional overloads, and this just nicely works. And if you actually look into such implementation, you can find out that actually such definitions are not more expensive and for sure are not worse than adding additional member function in terms of encapsulation. This is the same as another member function, right? Nearly the same cost, the same side effects. So friends are really not that much worse than member function. If you add member functions to your class with no issues and say that friends are wrong because they break encapsulation, it's not the case, right? Those have the same impact on your encapsulation process. Now, when I have those hidden friends, I have the same broken my float. When I try to compile it, I don't see the other overloads anymore. They just disappeared. Why? I will show you this in a moment. But this is a huge benefit because this actually makes our program compile much faster. Because in this case, when I try to compile this line of code with my float, I don't see any other overloads, so it is really, really fast. I don't have to analyze them. I don't have to compare them. I don't have to do ranking in the overload resolution process. Where they are hidden, I will show you using another example. I will add ABS to my int class. I added ABS, and I can call ABS with my int class, and it perfectly works. In case of template functions and function difference right outside, templated from here, I had to specify more, so I'm not lazy anymore, and this also works. But now the difference will be if I try to call it with qualified lookup, which I said is faster. If I try to call it qualified lookup, then the right code still compiles, but left one does not. The left one does not compile because the ABS function is a non-member function of my int, but it doesn't mean that it's a member of external namespace. It's not. It's a function that's associated with our type, and that's it. It cannot be accessed through qualified lookup at all. You cannot say it's a member of our class because it's not a member. You cannot say it's a member of any other namespace because it's not a member of another namespace. This is a special function associated with our type only, and it's being considered for overload resolution name lookup process only if your class is being used. Otherwise, it's invisible, it's hidden from this process. This makes the compilation faster, and this also makes the name of the idiom hidden friends. Right? So hidden friends are the friend functions that are declared and defined inside of the class, taking its argument, this type as an argument. Right? So this is what are hidden friends. And you should not have any other declarations outside, because still you may say, I will provide additional declarations outside. This will make it not hidden friend anymore. Even if it's defined inside, it will not be hidden friend if you provide declaration outside. So please don't. Be lazy. You may consider this a limitation, and that you cannot call it like this. However, I mentioned before that customization points, customization frameworks typically look for customization points using argument-dependent name lookup. This is how those work. And you typically use those hidden friends to limit big number of overloads, because those overloads actually are big because they are customization points. So those two nicely fit to each other. Engine that uses ADL only to find things, and things that can be found with ADL only in order to customize things. Perfect match, right? You should not call customization points in this way, because in this way you will actually not write generic code. It will be harder to maintain it, harder to refactor, and so on. Of course, we can extend it. We could talk about customization point objects, but we don't have time, and it's not the subject of this talk. But then actually the call site may be a bit different, and it will work for you really nice. So recommendation, prefer hidden friends functions rather than global non-member functions to overload operators or implement other customization points. Do it even if you don't need private class access. Even if public interface suffice, use hidden friends, because we want to be lazy, type less, and we want to have faster compile times. Friend functions are not a part of the candidate set for arguments of other types, which mean they improve compilation speed and also make shorter error messages, which is also really important. You see only relevant functions for your error message, and all of the others are gone. It's easier to understand those error messages, which are terrible in some cases. It's unfortunate that standard didn't use it earlier, and we cannot change right now. So yes, this monster streaming operator error will not be shorter, but you may not make it longer by not adding more. All right. Sometimes you want to write a class template where implicit conversions are not actually welcome. So I don't want to have this overload. I commented this explicitly because I don't want to have implicit conversions. But then you may have a problem. How to implement hidden friends? Because with hidden friends, I have to specify the argument of our type as an argument of a function. It is not template. It's non-dependent in this point, because this is not the deduced parameter of this function template. It's fixed t of this class, which means that this works, but it doesn't, because conversion works in one direction but not the other. So I just wrote an asymmetric interface, which is wrong. And be aware of that. All right? Adding to ints, fine. Adding 0 plus I works because 0 converts to this argument. But then if I have I plus 0, then this one doesn't convert from 0 because of this parameter adjustment process that is really limited, as we said. So what can I do? I can add another overload that has this exactly mirrored. Fine, that those cases don't work, but last one doesn't work because it's ambiguous. All right? And I see I have some broken slide here because I have some typo, sorry. I will try to fix it quickly. So maybe it will not be that. Okay, sorry for that. I had to accidentally type. Accidentally typed something. All right, and okay. The solution may be to make only one function template, not two like here, but one. And then to concept here. With this, both parameters are dependent on the parameter t. But I'm limiting this one to say this is only the instance of my type. With this, we don't have conversions as expected, as needed, and only this case works. So this might be a good solution for you. Unless someone comes to you and say, I want to derive from my int, which doesn't work anymore, but worked before for regular types. So you can do derived from. There's something that you can add here, and this will also work fine. You can also use an alternative thing that may be easier to reason about, not using those concepts. Or maybe you don't have access to concepts and you don't want to play with enable if in your code base, where actually you can make it easier. I call it hidden friend injection idiom, where actually you create a class that has all of those operators provided for not its own type. Those are friends. Friends using myInt as arguments. You cannot call those operators on myInt-based class because they are hidden and they expect the type they provided of the class here, so it will not work for this class at all. But if you add it as a base class to your class, then it works. Because you pass myInt instances, and then those will launch, even though they are even private in this class, and they have private inheritance here. And now you don't have to use concepts, you don't have to use requires expressions, you may use just myInt of t in both cases, which actually even works for derived classes, because we said that during parameter adjustment process, derived classes are also considered. All right? So I find the idiom really powerful and nice. It disables implicit, possibly asymmetric conversions for customization point arguments by putting all hidden friend functions in the base class. It also enables me to use it for types that I don't want to spell explicitly, the family of types expressed by some, for example, concept. Something that would be hard for me to spell. Let's see an example, and coming back to units. I have something called unit interface that basically specifies me what a unit is. All units are derived from unit interface, right? And then my unit interface actually provides all of those overloads. For units, I don't know what a unit is. I have plenty of types. User can define more types. I want to work with both, with all of them. But those are tag types. Tag types that are stupid. Well, tag types that inherit from unit interface, so not that tag types that much, but they all have friend functions. Like they are empty, they don't have any members, right? And by inheriting name unit and direct unit from unit interface, I make those satisfy the concept. And then if I derived again, because if you know my library, if you've heard about my talks, I prefer strong types over aliases. Then I may have meter and second here even, and even those are satisfied by those friend declarations. So I can write, for example, meter divided by second using this operator. As a result, I will be able here in this far away base class to actually create a type of direct unit meter per second, because I will know exactly LHS, RHS will be those end user types being used here. Right? So it did not convert to a base class like it was in case of myInt, because in this case, we're converting to myInt and we just lost information about the end type that was derived. With using concept, you can preserve those types and then benefit from the fact that you have all of the information about the type and still have hidden friends working for you, which makes compilation faster, error messages nicer, and I care a lot about error messages in my library. So to summarize, friend, it grants a function or class access to all private and protected members of our or another class, right? Introduces strong coupling between two otherwise independent entities. Sometimes it's fine, and then there's no problems. If it's not fine, then don't do it. Hidden friends functions, right? Because those are always functions. You cannot have hidden friends class. Do not break an encapsulation much more than a public member function does, right? So do not be afraid of them. And friendship is not mutual, transitive, or inherited. Use friend when compilation performance and compiler errors is a concern. So in 95% of all of the code bases, right? When external functions need special access. When two classes are tightly coupled but can't be merged together because, for example, they have different lifetime. Those are perfect use cases for friends. Avoid friends. Don't use this for unit testing. Don't do define public-private, right? Private-public. Don't use friend when you need only to give a piece of your monolith monster to some other class. Use those idioms that we discussed, right? It is possible to provide selective access only. And of course, there might be better alternatives, like dependency injection, single possibility principle, and so on. As you can see, as I said, friend is a powerful tool, but like art, it requires skill, understanding, and careful application. Avoid overuse, use it judiciously, and appreciate its nuances. Thank you, that's all.
Thank you very much, Mateusz. This time, I am going to start with a question that is not central, but as you mentioned the issue of unit testing, I have my own answer, but I want to get your answer because this repetitive question, how do I unit test private member functions?
Don't.
Great! I wanted you to say that.
Don't do it. You can always
Never.
put the member function, do the other class, single principle. You can always extract it externally, outside of the class, right? Personally, I'm not using static functions. Typically, I don't do private functions. I much more prefer to put a function in the public scope and just pass members, if needed, as references to this function. And then you can test it. And it's fine. You can put it in a detailed namespace, whatever. It's hidden from the user, not being the API of your library. It's okay. But if you're doing single possible principle, none of those should be needed. Just have nicely encapsulated small classes that do one thing, and then you don't need any of those.
Good. I wanted you to say that. And by the way, define private public is undefined behavior. Yeah, questions?
Well, thanks for the talk. Back on the unit testing, this is like a struggle I have personally, like to test the internals of a class or not. One problem I realized that if you don't test internals, and then like maybe refactor out individual pieces to atomic units, but then you do the same trick when you combine them together, then you still need to check the internals. Do you have a solution for that?
I'm not sure if I follow. If you are able to exercise 100% coverage of branches and code base per each entity separately, you don't need to repeat it for entire code base, right? You need some integration tests to make sure that the integrated blocks together correctly. But besides that, if the functionality of each block works properly, you don't need to test anymore. And actually you have less tests, and you can exercise more branches with that, because with monolith it's actually harder to exercise more branches.
So let's say like you have two components, right? And one of them depends on the other one, so you inject it. And it's internally used, and you're not allowed to check the internals because you just test the public API. So you may have like a couple of these, they come together, and then you have no idea what's going on in internals because you don't want to test those. So that's, even though they're individually tested, but when they combine, the combined unit, you don't test the internals of the combined unit because you don't want to test the internals. And this is a problem, I think. Do you have a solution for this?
Well, with injection, it's always this problem that you can never actually test all of the possible combinations because you never know what will be provided as an injected type into, right? So you still provide explicit types, and those types should be tested. And of course, if there is a possibility that two types will behave differently than each type separately, then you need to provide some specific tests for the integration tests. But those are much less actually tests to write than you have to write for all of them. And still, you can probably, and you should, depend on the public interfaces to test them, because this is what users observe.
More questions?
I once tried to. Do you listen me well? Okay. I once tried to write an overload for an insertion into an O stream for STD pairs in order to print items for a map, and then try to print those items through an O stream iterator. Okay. And I could not compile the code because, according to some information I saw in Stack Overflow, this OStream iterator algorithm, was trying to find through ADL this OStream. So since this OStream overload was not declared in the same namespace as STD pair, I am pretty much screwed and cannot, print all of this. Is the only solution trying to write a wrapper class to allow conversion from and to the STD pair, since I cannot inject anything into the STD
Sure.
namespace.
Of course, but this is actually not different question, right? This is the question about overload resolution, about the functions that are provided already by the standard and which are not. And in the standard, will not provide streaming operator for integer, right? Or pair of integers. And we are not allowed to add anything as users to the standard namespace. So you officially cannot do it. Of course, it will work, right? But you cannot do it in order officially to make it work as needed. My solution for this would be to make any of those types user-defined type. You can wrap integer in your type. You can create our own pair, and then it will work because it will be your type from your namespace. Your namespace will be looked with ADL for overload, and this will perfectly work. Dismar, do you want to add something?
Well, I just wanted to say, make one of the arguments a strong type, and you're better off anyway, and then you can locate the output operator in that namespace.
Yeah, exactly. Unfortunately, you cannot add overloads for stud types and fundamental types and the same specializations are not allowed for those types. At least one of them has to be user-defined.
Cool. Hi, Mateusz. Thanks for the talk. It's very instructive. This is a question more about the templates and how it take a long time. You actually mentioned that it's more due to the name lookup, right? That's something that you mentioned in the...
And it often is. I'm not saying that it's the only reason. Of course, templates may take time, especially if you remember those times where Boost was dominant in 2004, 2006. Those metaprogramming tricks didn't use overload resolution and were compiling really slow, right? So I'm not saying that templates are for free, but typically people complain and blame templates where it's not the case. So try it first, and then, of course, you can blame templates after that.
Yeah, no, I guess I just wanted to better understand what you mean because, well, I was going to cite Boost. I have a project that I work on. We heavily use multi-precision from Boost, and I had a lot of problem with compilation time increasing. And I guess I just wanted to know what exactly you mean, name lookup versus the template, and if you'd have any tips, for people who are using Boost and such libraries to reduce compilation time.
Yeah, tips. The best tip is to use hidden friends to limit the overload set and to use a qualified lookup. So to basically eliminate all of the fuzzy logic of finding a name. Right? This improves performance a lot. If you need more, then I refer you to my talk and maybe my trainings, right? But right now we don't have time to discuss the overload resolution and lookup much more.
Any other question? So, thank you very much.
Thank you.